In example 1.12, we explored the idea of classifying mappings, and we found that there were 4 different types of classification. There is a one-to-one, many-to-one, one-to-many, and many-to-many type mapping. Now, as it turns out, there are only 2 types of mapping that are going to fit our next definition. These are called the one-to-one and the many-to-one type mapping. And the reason why we are so interested in them is because they fit the definition for being a function. So one of the beautiful things about being a function is that every value that we try to map can only be used one time. So let's look at the definition 1.9 a little bit further to see where that language comes out. It says, let A and B represent sets. And then a function from A to B is a set F of ordered pairs. So it tells you preliminarily what a function is. It's something that occurs from A to B and is a set of ordered pairs. So it tells you essentially what this notation right here is telling you. This gives you the name of the function, which in this case is function f, and it also tells you what is the first set, that would be set A, and it also tells you what is the second set, which in this case is set B. So what I have underlined right here represents this notation, which is not unfamiliar. We've seen that already in the course. But there's some stipulations here, because up to this point, we've just generally been saying, create a mapping however you want by using a connection or a correspondence between 2 sets. But now we have the words such that, which means that there is a condition. There is a specialization here about the map that we're going to be creating. And it says that for every A, little a, that is an element of big A. So when I think about this from an arrow map perspective, I'm going to have set A, and I'm going to have set B, and I'm making a connection from set A to set B, and in this case we're calling it F. That's the map. It doesn't say some of the A or the elements from A that you choose. It says that you have to use every single A. So whatever ends up going right here for set A, you have to use every single element that is there. When you use each one of those elements, it says that there has to exist a unique element from set B. So really what that is telling me is that I am only allowed to use each element from set A. So let's say that set A has 1, 2, and 3. I am only allowed to use 1 time, I can use 2 one time, and I can use 3 one time. I cannot use them multiple times. Otherwise, I will be violating the uniqueness part of this definition. And that is what takes out the many-to-many and the many-to-one type mappings as being a possibility here. So with this, we also have an extra note here talking about this statement A comma B being an element of F. So when we're talking about a function, we are talking about a particular type of map, which means we're talking about a set of ordered pairs. So there is something called function notation, and that's what this is right here. This is called function notation. And the function notation is another way for us to be able to talk about an element from the first set being mapped to an element of the second set, and it also says specifically what is the name of the map. So we will be using this function notation to be equivalent to this notation right here, which tells us that we have a particular ordered pair that is a member of this function. So those things are equivalent.